Lesson 5.6 Examples part. So we're going to solve questions that will come on the exam based on the questions solved in the book. So first off, we have this question, which gives us 3 secant x minus pi over 3 minus 3. So first off, we should note that it's secant. So if we were to find the domain, we should make sure that the domain of secant is all multiples of pi. So if we write here b to x plus c, which is this, is not equal to, and then the domain, which is 2n 1 pi over 2. Now, we should make sure to mention that n belongs to z. N belongs to all real numbers, not z. And this means that n belongs to all real numbers, and you should mention this, or else you might lose grades if it's subjective. So now we do x, now we just substitute this with this, and then we get x minus pi over 3 not equal to pi over 2, 2n plus 1 pi over 2. And then if we just shift solve this, if we move this here, then we solve, we're going to get x is equal to 5 pi over 6 plus n pi. That will be our domain. Next up, vertical asymptote. And the formula for vertical asymptote is basically this, except it's equal to. So if we were to do so the answer, instead of being x is not equal to, we should make sure here x is not equal to, so this is our answer. In the vertical asymptote, it'll be x is equal to, and then we can just use our domain answer. So this is our answer. X is equal to, and that's vertical asymptotes. And now here it asks us to find two values of vertical asymptotes. It wants us to find two different vertical asymptotes. So how we do this is we take this formula, and n stands for any real number. So we could use any numbers we want, and we can find vertical asymptote 1 and vertical asymptote 2 using this formula. So we do 5 pi 6, and then for example, we take n here is equal to 1, or instead, we can even take 0 if we want to make it easier for ourselves. And then we do 0 pi, and then the answer will just be 5 pi over 6. So 5 pi over 6, and that's our first vertical asymptote. And then the next one we can do same thing, except 1 instead. So n is equal to 1. And then we get 11 pi over 6. And that's our answer. Next up, we have the period. And as you know, period of secant is 2 pi. So 2 pi. So 2 pi over b, which is the formula for any period, is going to be equal to 2 pi. So knowing this, we can simply solve it. 2 pi over 1. Why is b 1 here? Because look over here. So we should probably mention what a, b, c, and d are. So a here is equal to 3. B here is equal to 1. C is equal to pi over 3. And then D is equal to negative 3. Why is it pi over 3? Because here the formula is x minus C. So C has to be positive. And then D is equal to negative 3. Now, knowing this, B being equal to 1, we know that the answer is going to be equal to 2 pi. So that is the period. Next up, we have the range. Now, the range formula is simple. We do negative infinity d plus or minus a, and then brackets, make sure it's brackets, union d plus or minus a, and then to positive infinity, parentheses. Now we can do this and just substitute d, so we have d value is -3. So usually we do the smaller value first, so we'll do -3 and then -3. So then union, then you'll do +3 here, then do -3, then +3, and then gives us plus infinity. And then our final answer will be the interval notation of -infinity -6 union 0, this is brackets, into positive infinity. Now our x-intercept, because our range does include 0, then we have infinitely many x-intercepts. Now, if our range didn't include 0, we would have no x-intercepts. Now, amplitude, as usual, none. And then there's one more we want to do, which is 8, which will be the y-intercept. Now, the y-intercept is really easy. All you have to do is substitute the value into y. So we do 0 equal to 0, sorry. Y is equal to 3 secant -pi/3 minus 3. As you can see, the x is 0, so we just remove it completely. Then we do 3 and 1 over cosine minus pi/3. Write it a little better. Which is equal to 3. That will be our y-intercept. You can obviously just use a calculator for this, and that is the first question. Now, for this next question, we're going to do the transformations of this function. Now, this function is -4 plus 2 secant 2 pi x minus 4 pi. Now, the first thing you should know is that this right here cannot be used. We need to rewrite this equation. So we're going to rewrite it again as -4 plus 2 secant. And for this right here, we want to isolate b. We want b to be alone. So to do that, we can factor 2 pi. So we can do 2 pi here into we can do 2 pi here into x minus 2. And that will give us the same answer. So if we multiply this, it'll give us 2 pi x minus 4 pi. Now, why do we do this? Because now we can see clearly what our variables are. So we have d, so d is equal to -4. We have a is equal to 2. We have b, it's now clear, b is equal to 2 pi. Then we have c, which is equal to 2. So we have a, b, c, and d. Before, we don't know if it's 2 pi or not because it's mixed. We need to isolate b. Now, after we do that, we can start with the transformations. So we can start with whichever one you want. We can do vertical, do the easiest one, which is vertical shift. So with this equation, there is a vertical shift of -4. So we'll write vertical shift. Since it's negative, it'll be downwards. So 4 units. 4 units down. Next up, so that's the first one. Next up, we have phase shift, right? It's moving either left or right. So we can write here phase shift. So it's 2 units and it's not negative. So C isn't negative. So it's going to be 2 units to the right. Next, we have a horizontal shrink because we have a b value. So it'll be a horizontal shrink. Now, why is it not a stretch? Well, if you look here, b is greater than 1, it'll be a shrink. And if b is less than 1, it'll be a stretch. And we have no negative. So it'll be a horizontal shrink by a factor. Now, you should know that it's a horizontal shrink by a factor of 1 over b, because in horizontal shrinks and stretches, the factor is 1 over b. But in vertical shrinks and stretches, it's the same value. We don't flip it. So here it's going to be by the reciprocal of b, so it'll be 1 over 2 pi. That'll be our factor. We do have a here. So we have a, so it'll be a vertical. Now, is a greater than? Yes, it's greater than 1. So it'll be a vertical stretch by a factor of 2. We do not flip it. 2. And that is all the transformations. Next up, we have cosecant questions. And now, before we get into the questions, we should firstly rewrite this formula because we don't have an isolated b. So let's isolate it quickly by doing y is equal to 2 cosecant, and then taking 2 out, and then we have x plus pi over 8 plus 1. Now we can easily now mention all this stuff, or all the functions. So we have a is equal to 2, not functions, all the values. B is equal to 2, C is equal to negative pi over 8. Why is it negative? Because it's positive, and minus times minus, minus gives you positive. So it's going to be negative, and then D is 1. Now let's start with the domain. Now the domain of this function, of the domain of cosecants in general, are multiples of pi. So knowing this, we can do b x plus c going to not be equal to n pi. And we should mention that n belongs to all real numbers. Now, just quickly substituting this formula. It's 8. We can quickly find the domain. X will be equal to n pi over 2 minus pi over 8. Next up, we have the vertical asymptote. And as I said before, it's going to just be equal to x is equal to instead n pi over 2 minus pi over 8. Now we can use this formula to find two vertical asymptotes. So we can have n is equal to 0 and n is equal to 1. N is equal to 0 will just be equal to x equal to minus pi over 8. And n is equal to 1 is going to be pi over 2 minus pi over 8, which is equal to 3 pi over 8. And those are our two answers. Those are our two asymptotes. Next up, we have the period. Now, the period of cosecant is 2 pi. So 2 pi over b going to be equal to 2 pi. Now, we know that b is equal to 2 here. So it's going to be equal to 2 pi over 2, which is going to be equal to pi. And that is the period. Now, for the range, we already know the formula for it. It's the same thing. It's going to be negative infinity to d plus or minus a, brackets, union, d plus or minus a into positive infinity. So knowing this, the answer is going to be negative infinity into minus 1 union 3 into 3 into, what was it, infinity. That is the range. Now the x-intercept is going to be equal to none, or no x-intercept, because the range doesn't include 0. Now if the range included 0, then it would be then there would be infinite amounts of x-intercepts, and obviously no amplitude. Now finally the y-intercept, last one, it's going to just be substituting the x here with 0. So it'll be 2 cosecant pi over 4 plus 1, and then 2 into 1 over sine pi over 4 plus 1. So then y will be equal to 1 plus 2 radical 2. So we have to also remember to write the interval notation of the x-intercept being 1 plus 2 radical 2 plus 2 radical 2. And that is the y-intercept. All right, next up we have the tangent. And the tangent questions are quite simple. But first off, we need to obviously rewrite this equation. So first off, let's do y is equal to 3 tangent 3 tan into pi. And then we can just close it off with x plus 1 minus 2. Now this is our new radical equation. So a is going to be equal to 3, b will be equal to pi, c will be equal to -1, and d will be equal to -2. Now that we have the 4 values, we can start solving with the domain. So the domain of tangent is going to be odd multiples of pi. So we're going to write b to x plus c is going to give us, now going to be equal to odd multiples of pi. So the formula is 2n plus 1 pi over 2. And we should also mention that n belongs to all real numbers. Now we can just continue solving and substitute this with this. So it'll be pi to x plus 1 not equal to 2n plus 1 pi over 2. And eventually you will reach the answer of x is not equal to -½ plus n. -½ plus n. So that is the not equal to. So that is the answer of the domain. Now the vertical asymptote is going to be x is equal to -½ of plus n. Now for the two vertical asymptotes that we're going to solve, we can change color. Okay, we can do n is equal to 0 and n is equal to 1. Now for n is equal to 0, x will be equal to -1 over 2 because n is just 0. And for when n is 1, then x is going to be equal to 1 over 2. Next up, we have the, make sure that's 1 there. Next up, we have the period, and to solve the period, we should make sure to know that it's tangent, and when it's tangent, the period will be equal to pi. Now knowing this, now knowing that the period is pi, we can do the formula pi over radical b, which is equal to pi over pi, because b is also equal to pi. So the period is going to be equal to 1, and that is the period. Now the range, on the other hand, for tangent, is all real numbers. Now you can just memorize that. The range for tangent is all real numbers. Now the x-intercept, because the range is all real numbers, there's going to be an infinite amount of x-intercepts. So infinitely many x-intercepts. Now there's no amplitude. Now finally for the y-intercept, we're going to substitute x for 0. So it's going to be 3 tan into pi minus 2, which is going to also be equal to negative 2. Just put it in the calculator. And that is going to be it for this question. Now, for this final question, we have cotangent here. Now, the cotangent questions are quite simple. First of all, let's quickly name out the variable values here. We don't have to rewrite the question because it's already written in the simplest form. So A is going to be equal to negative 1, B is going to be equal to 2. We don't have any C here. And D is going to be equal to negative 3. Now, knowing this, let's solve for the domain. Now, the domain of cotangent, you should know this, is going to be multiples of pi. So it's going to be b into x plus c. It's not equal to n pi. And obviously, n belongs to all real numbers. Next up, we can just substitute this for 2x. So b2x is going to be not equal to 2 pi. And then x is not equal to n pi over 2. So that is our answer. Now, vertical asymptote is going to be, as usual, x is equal to n pi over 2. And then finally, obviously, it's going to be opposite, right? The vertical asymptote is going to be equal to instead of the domain being not equal to. Finally, the two vertical asymptotes, so we have n equal to 0, n equal to 1. Of course, you don't have to pick these numbers. N could be any real number. It could be 300, 400 if you want. It doesn't matter. So if n is equal to 0 in this case, x is going to be equal to 0. If n is equal to 1, x will be equal to pi over 2. So you can just pick the easiest numbers if you want. Period. So the period of cotangent is going to be pi. So just like the period of tangent. So knowing this, then it's going to be pi over b is equal to pi over 2. And that is the answer. One period is pi over 2. Now the range for tangent and cotangent is all real numbers. So go ahead and write all real numbers, just like that. And since it's all real numbers, there's going to be an infinite amount of x-intercepts. So infinite many x-intercepts. And then finally, the amplitude is none. Now for the y-intercept of this question, it's a little different. So this question, the y-intercept, we substitute x for 0, it's going to be minus cotangent of 0, minus 3. Now, when we do this, now we have to switch this. Now let's quickly switch this to minus 1 times 1 over tangent 0 minus 3. Now what do you notice here? Tangent 0 is going to be 0, which is undefined. So making this whole equation undefined. So x equal to 0 will be and is an asymptote. And that is the answer for this question. That'll be it for lesson 5.6 examples video. If you have any questions, you can ask them down in the comments or in the server, and yeah, good luck.